How's it going? We're back for day 11 of Advent of Code, and I've got my project set up, and we're just going to jump into the problem. I've got about an hour or so to spend working on it uh, this day, or during the day, I should say, not this day, during the day. And then whatever I don't get to right now, we will circle back this evening to finish it off. So let's go. Day 11, Plutonian Pebbles. The ancient civilization on Pluto. Let me move my mic, actually. Espresso. Got my mic, got everything I need. Okay, now I'm ready. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. Hold on, this seems like... How does this tie into our story at all? Did I not? Maybe I missed what was going on day 10, but I feel like this is like... Oh, because we're on Pluto, I guess? I don't know. I was a little lost there for a second. Okay, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Excuse me. Sometimes the number engraved on a stone changes. Other times, a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 1, it is replaced by a stone engraved with the number 1. No. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. So that's the splitting. The left half of the digits are engraved on the new left stone, and the right hand of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros, so 1,000 would become stones 10 and 0. If none of the other stones apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take a note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99, and 999, and you blink once, the stones transform as follows. The first stone goes to 0. The first stone becomes a stone marked by 1 because it had 0 on it. The second stone is 1, and that's an odd number of digits, so it's multiplied by 2024 to become 2024. The third stone is 10. It's even, so those digits get split into a stone marked 1, followed by a stone marked 0. The fourth stone, 99, is split into 2 stones marked 9 because it's even. And then the fifth stone is an odd number of digits, so it's replaced by a stone marked 220. What is that? Is that 2 million? 2,021,976 because we're taking this multiplied by 2024. So after blinking once, your 5 stones would become an arrangement of 7 stones engraved with the numbers. Here you go. Here's a longer example. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,312 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? It's not readily apparent to me how you would solve this without iterating. But maybe there's like a mathematical solve for this somewhere in here, but I don't. To me, it doesn't jump off the page, so we're gonna do it iteratively. So I think what we want to do is we actually don't want to since we're just trying to get the number of stones. I don't think we ever want to actually coerce this into integers. I think we want to just treat these as strings. Well, I guess we'll have to coerce them to. We'll have to parse odd length strings to integers so that we can multiply them. Or will we? Will C# just do that implicitly for me if I try to multiply? I honestly don't know. Multiply a string by an integer. I don't know what'll happen there. We can try, but the reason why I'm saying I think we want to keep it at least in strings partially is because of this. When you have to split something, I think it will be much easier to split the string and remove leading digits or leading zeros. I think that will be a much easier task to do working with strings, personally. So, okay, let's go. What are we calling this? A list of stones. So theoretically, we could have a stone class, right? Because this is what I'm thinking. I'm thinking we have a stone class, and that has a method on it called split, and that method handles this transformation that is described here. So the stone takes in its string representation, and then stone takes in its string representation, and then we can call split on each individual stone to transform that stone into to transform that string into the new string it should be. Well, no, because that doesn't help us. It doesn't help us because when we call split on the stone, we probably want to return back some stones. Or maybe we don't call it split. Maybe we call it transform. And that transform method can hand back one or more stones. And then we just continue to build up our list of stone, our total list of stones after all the transformations are done. That's how I'm going to start. It might be wrong, but that's where my mind's going. I think complexity-wise, this isn't terribly complex. At least part 1 doesn't seem to be the case. I could be wrong. Part 2 might come smash me in the mouth and make me regret what I said. But yeah, I just think. Yeah. I mean, I could also have. Yeah. I'm trying to think if I want to do this any differently than that, but I don't think I do. Yeah. Okay. So let's start with my idea here. So we're going to have a class. Let's close this, give us a little bit more real estate. I think this is big enough. It looks big enough on my screen. That's 16-point font. and 18 seems kind of cramped to me, so I'm going to keep it at 16. So we have a class called Stone. It's going to take a string. Actually, how about we stick with our little kind of our rustacean syntax that we've been using, where we're gonna have a private read-only field that's going to be stone. Not private read-only. Private read-only string that is a stone. Sorry, got a message. Yeah, okay, so we'll have private read-only stone. And then we'll have a private constructor, we'll call it stone. That'll take a string, which is the stone. And then we'll set the stone to stone. We'll have a public static that returns a stone, and we'll call it from string. Just gonna call this input. You can say, we can actually do a nice little expression, say new stone and input. Okay, then we can actually read all, we don't want to read all lines because I think our input is just one line. So we actually want to do read all text sync. Then we are going to say bar stones, and that's going to equal input dot split on an empty space. And we're going to trim our entries, and we're going to also remove empty entries. Then we can say select. We can say give me the string and say stone dot from that. Yeah, so now we have our stones. We can actually just do that. Okay, so we have our stones. Now we need to implement the logic for the transformation. Yeah. Yeah, I'm just thinking about how I paused for a second because now I'm thinking about how we would iterate over this, because we're basically going to go over it. We're basically going to transform the stones a certain number of times. The thing is, though, when we're handed back new stones, we need to transform. We need to run transform on the new stones. So that's just something we need to think about. So my API here might not be exactly the most ideal now that I'm thinking about it, but let's continue to pursue this just because that's where I've been at. So this one's going to have public public list of int. It's going to be public. It's going to return a list of int, and we're going to call it transform. And then yeah, transform, and it's a list of int because it's going to be, it could return 1 or it could return 2, right? Depending on what is held as its string. So the first thing we need to do, the first thing we can say is we can say if stone is a 0, then we know we want to return this. Oh, and this actually is going to be a list of strings, is going to be a list of stones. Or not, list of int is going to be a list of stones. So we'll say return new stone. Oh, actually, instead of calling, this is kind of redundant, but instead of calling, instead of using this, what we're really passing in here, the value that we're really passing in here is what's engraved on the stone. So I'm going to call this, I'm actually going to call this engraved value. Yeah, rename them all. And then I'm also going to call this engraving. Oh, yep, we don't need to say stone, that's redundant. Okay, so if it's an engraved value of 0, that becomes a stone marked with 1. The second stone, 1, is multiplied by 2024. Alright, here's our rules. Then it returns 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on. Okay, so we need to figure out if it's even or if it's odd. If it's odd, then it's pretty straightforward, because if it's odd, we just return that value. So let's check if it's odd. Var is odd, or var has odd number of digits. And so the way we can do that is we can say if engraved value dot length mod 2 is not because if something is divisible by 2 with nothing left over, then it's even. So if it's not divisible by 2, it's not evenly divisible by 2, then it has an odd number of digits. So if it has an odd number of digits, we can var num equals int dot parse engraved value, right? Because this means it's an odd number of digits, which means we want to multiply it by 2024. So we'll say var num return a list of new stones, which are going to be the number that we just, the engraved number times 2024. Engraved number, like that. var new engraved new engraving value engraved equals engraved number times times 24, like that, and then when we pass it in here, we'll turn it into a string. New engraved value dot toString. Now we just need to handle our last case. So if we've gotten down to this point, we know we have an even number of digits. So what we want to do is we want to find the midpoint. We want to split it. We want to trim it, and then add it. So we're gonna do our middle index. Right? Is that the right middle? Yeah, middle index. We'll say what we say. We will say engraved value dot length divided by 2, and then we'll say var. What is it? It's going to be from the left. So var left part. No, left. I'll make them left digits equals engraved value dot substring, and then the length. So substring takes the start index and then the length. So we can't use the middle, can we? Oh, no, we can't, because we're going to take an even number. So this isn't actually the middle index. This, we can call this parts or parts length. Not sure the best way to express that, but that's the length of each of the parts. So we can say substring 0 parts length use range indexer. Oh, okay. And then the right digits are going to be the engraved value. They're just basically taking the other. So we'll say engraved value from the I don't want to say engraved value substring, because what I want to do is I want to take basically that index to the end. So this looks odd to me. So I am going to turn this back to... Whoops, I didn't mean to do that. I am going to take this back to F2 middle index. And I think that makes more sense too with the range indexer, right? Because we're basically saying from the middle index to the end, and then from the start to the middle index. Then there's one other thing we need to do here. We need to make sure that we trim the start for any leading zeros. Does this not have a trim? Oh, the character is 0. There we go. Start. And remove all the zeros. And those are our stones now. We don't need to do any other manipulation because we want them to be strings. So then this is where we'll return left, and we'll return right. Oh. They should be new stones. New, left, new, right. Cool. So now we can actually write some tests for this. So let's do that. And we can actually use the cases they gave us. We can make ourselves a data-driven test, which are the best kind of tests, stone tests. So the first thing we'll do is we're going to have a record, and we're going to call this our test case. I'm going to call this transform test case. And so this is going to have a string, which is the engraved value, and then a string with the expected with the transform. And that's just so that we can have an object that represents the parameters to our tests. And then the way that TUnit does this is we're going to have a public method. I actually don't know if this needs. I think it needs to be public. So public I enumerable of func, and that func just needs to return a transform test case. This. Let's see, and then this is going to be called transform test cases. There's going to be a method that we call. And this needs to be public. It's going to complain. Yeah, I know it's never instantiated. Okay, so then what we're going to do is we're going to yield return. And the reason why you do funcs, or the reason why TUnit wants you to return a func is so that when it gives this func to your test method, it can create a new instance of your test data per test, right? So so tests aren't sharing the same instance. So this is going to be a new transform test case. And so if our engraved value is 0, then we can expect our transformed value to be 1. And then we can continue to add to this. We can just, because this is an enumerable, we can just add more yield return statements that return more and more test cases. So now I'll actually write my test method, test public async task, and this is going to be transform when called should return expected, should return stone with expected. And then we need to decorate this with a test, the test data, and then we say name of this. And then to our method, we will have a transform test case parameter like that. And so now what we'll do is we'll create a new stone. We'll say var result equals a new stone from our test case dot engraved value. and then we'll say transform that. Oh, whoops. We need to say stone dot from, transform it, and then we need to assert await assert dot that, whoops, dot that result dot is equal to or equivalent to. I think we want, I'm going to do is equal to, and I'm going to say new stone test case, or no, not new stone, stone dot from test case dot transformed value. Why can't it? Broken something. Oh, so I think if I, so what I was going to say is I think I want to make my stone a record. That way I can compare them based on bar expected equals this. This is going to be equal to expected. Oh, this is a list of stone. So we actually have to say, again, we have to say is equivalent to. Oh, shoot. So that means in our test case, we actually need a list of strings like that, transformed values. And then up here, we're actually going to need to do var expected equals test case dot transformed value. We'll select, we'll create a new stone from each of them. We'll convert that to a list. And then now we can just say expected. That should work. And why is this complaining? Constructor test data. Am I using the wrong attribute? I'm missing something. I did this in an earlier. Where did I? Oh, method data source is the attribute I want. Method data source. There we go. And oh, we can make this private, which means this. Oh no, that has to be public. But why? Oh, it's a static. Public. Public. There we go. Okay, so this I would expect, this test right here, I'd expect to work. So let's run that really quick. Where's that tab? I think I just need to build it. So build the solution. Drink some coffee. Oh, hey, Steve. I didn't see you guys in the chat. Hi, Steve. Not. I see. Not brand new to C#. I'd say I'm probably an intermediate, leaning towards advanced. I've written a lot of C sharp, but I've not been doing it in a different language every day. I've just been doing it in C sharp, and I've just been adding a project to my solution. Uh, so yeah, what's up, chat? Sorry I didn't see your guys' messages earlier. Yeah, I'm working on day 11 of Advent of Code. I'm doing it in C sharp. This is my second year of doing it. I did it last year, and I also used C sharp last year. And yeah, we're just trying to. I'm using some of my lunch break to sit down and work on this. I've been the first like 8 or 9 days. I've been staying up to like 1 o'clock in the morning, trying to get them done each day. But I decided I would start kind of breaking it up into two chunks. Do part of it over lunch, and then try. If I can't get through it all, then come back a little later in the evening and finish it up. Okay, so let's see if this passes, which I would expect it to. Okay, so now what we can do is, now that we have this data-driven test, we can just add new cases down here. So, well, actually, let me put that back over here. And put that over here. And let's get some of these other test cases that they gave us. So one would become, we had one, that would become 2024. And if we had yield return, if we had a stone that was engraved with a 10, we would expect to be handed back a 1 and a 0. And if we got, if we got 99, we'd expect a 9 and a 9. And if we're a 99, we'd expect one big value back. So 2, 2, 1, 9, 7, 6. So those are kind of the base examples they gave us. So let's rerun our tests, which is the nice part, right? Of having a data-driven test, you just add test cases and you don't have to update any of your test code. So let's run this again. They all pass. I think they all pass. Let's tab. Yep, they all do. Okay, so that's a good sign. Which means what does that mean? That means I want to try this. So what I want to try to do now is what I'm going to do in my main method. Well, actually, I think I'm going to make a new class because the person that's blinking is me. So just sticking with that same object-oriented approach. Let's say class. Observer, and then I'm going to say I have one method here that's called can actually be a static method, can it? So public static, and what's that going to return? I guess just a string. Just going to return a string. Excuse me, it's just going to return a string. Also, I've got about 20 minutes left before I have to pause for the day, and I'll come back this evening. But I think what I want here is I want an observer, and I'm just gonna stick with this fluent thing that I've got going on here. So I'm gonna call it a private read-only list of stones. And I'm gonna say we have a private constructor, takes a list of stone. Stones equals stones. And then I'm gonna say I'm gonna have a public static that's called that returns an observer, and I'm gonna call it observer.up of stones. A list of stones, and then it returns an observer. And I can say something like var observer equals observer.of stones. Why doesn't it like that? Because it's an enumerable. I mean, enumerable is actually fine. I could work with that, but I don't really need to have a really generic. So this is my observer, and then my observer is going to have a method that's like my observer is going to have a method that's called result equals observer dot blink, and that's going to take in some number, in this case 25. Yeah, I think that's reasonable. I can say public string blink int times. Now I'll just return an empty string. Then I'll go write some tests. Let's see. Class. I'll call this an observer test. It's a test method. Public async task when blink in blink when called it should return expected. I'll just go with that. It's very generic, but that's what we're testing for. So we can have a private read-only, and we can actually just make this an observer, and we can have our observer, and then we can say equals observer.of. We can give it a list of stones here. What should this be? This should look like new stone. And we're just going to start with what they've got down here. So we'll say stone of 125 and a new stone of stone. I don't want to repeat that so many times. So I'm actually going to do this. Excuse me, I'm going to say private read-only string example input equals a string like this. no, example input. It's going to be a string array equals what? It's going to be 125, 17, and then here I'm going to say example. Oh, I can't do that here. I have to do that in the constructor. Say this public server tests. Say observer equals observer dot of sample input dot r sample stones equals example input select stone from dot to list. So that's our test observer. I don't know. Maybe it makes more sense to say observer dot observe instead of. I don't know. Maybe that's not very clean. It when I initially thought of it, I was like, "Oh, that's really nice," but maybe it's not nice. So this can also be a data-driven test, I think. Can it? Yeah, actually, I'm wondering, let's get rid of all this now that I think about this. Let's get rid of all this. Should we get rid of this? Let's get rid of... Sorry, I got a message. I've got 12 minutes here. Let's see if I can get at least my tests set up. So what I'm trying to think through is I actually want this to be kind of data driven because I want to be able to say, okay, given the initial, right? I'm gonna create an observer that's observing an initial set of stones that looks like this. I'm gonna have a set number of times of blink, and then I'm gonna have an expected return value that I should get. So I'm gonna make a record called blink test case, and that is gonna be stone. This is gonna be a string array. It's gonna be stones, and then the next thing I want is an int that represents number of blinks. And then the last thing is a string that's the expected I'm just going to call it expected value for lack of a better word. It's a string of stones. It's a line or expected line of stones. Let's do that. Number of blinks would be capitalized. Then we can have a method that's called a public static method. That's an enumerable of func blink test case, like that. My record needs to be public, otherwise it's going to complain. Then I can say, call this blink test cases, and I'll just start yield returning. So I'm going to yield return a func that's going to return a new test case, and the test case is always just going to have that example input. So I'm going to make this private static. Rename this input, then why is that complaining? Maybe it's just complaining because I don't have all the other. So we're going to say if we blink 0 times, we should do nothing. It should return nothing. Or it should return the exact same thing that went in. So this would be example input. Or no, it should return those numbers. It should return those numbers. So it should return that string. Like this. So what we'll do in our actual test method here is we'll say method data source name of link test cases now are test case. And now instead of creating the observer up here and holding that in a field, we're actually going to do that in our test. So we'll say var var stones is going to equal test case dot stones dot select, and we'll turn them into actual stone objects. And then we'll say to list. Then we'll say var var observer now equals observer.of those stones. Then our result will be var result equals observer.blink test case dot number of blinks, and then we'll assert that. Let's see, that result, which is a string, is equal to test case dot expected stone. So I think right now this should fail. Rebuild. We should see a new set of tests over here. Observer. This guy should fail. Yes, sir. Yes, sir. Yes, sir. Okay. Yeah, because we're just returning string.empty at the moment. So I think we just want to say, hey, if times is less than 1, we're just going to return the stones dot, or actually we're going to say string dot join. We're going to join by a space, and we're just going to give it the stones back, which should make our first test case pass, I think. Excuse me. Expected result but found stone. Oh. We need to say stones select stone dot toString, like that. And then we need to override that method on the stone. So we are going to have public override toString, and we're going to represent this stone with its engraved value. So we'll just return engraved value. There we go. Now we go back where we want. But we should add a test. I don't have time to implement any more of the solution, but I do have time to implement a test for our toString method. So we can say async task toString when called, it should return integrate, say, our result equals new, or no, stone dot from, let's just give it a 0, to string on it, and then we can say await cert dot that result dot is equal to, and we'll actually just use a variable here so we can make sure we don't do anything weird. Decorate this with a test attribute. That. It's fine, I'll leave that the way it is. What is 10? Yeah, nice. Okay, so we don't have part 1 solved, but I think we're very close. I just need to implement to make these other iterations pass in my tests. And then I think we should be able to get to part 2 very quickly when we come back this evening. So, you shouldn't need. Oh, that's a good point. Sorry, I didn't even see your comment, but that's a great point. So if I go back, what Steve said to Steven in the chat right now was that when I'm doing this, when I'm doing this and I'm calling toString, I shouldn't need to do that because it will just implicitly do that. So let's go back, post tab. Nice, that's even better. Yeah, that's even cleaner. Thank you, Steve. I appreciate that. I will actually be back. So this took me about an hour to get to not solving part 1, but I'll get back on after work, after things settle down this evening. Actually, after basketball practice. My oldest son has basketball practice, so I'll be on later tonight to actually get part 1 solved and then solve part 2. So, thanks for sticking around. I'll see you guys in a bit. Good evening. We're back for part 2, or I'd say we're back for session 2 of trying to solve day 11. I haven't actually done part 1 or part 2. I just worked on it a little bit over lunch today and got most of the way, I think, for part 1, but still got to actually finish the implementation. Definitely took me a minute to convince myself to get back on here. Wasn't quite feeling it this evening, but we're gonna do this. Where we're at here is we're basically working on our blink method and making sure that we are transforming our stones for the given number of iterations or the given number of blinks, and then handing back the right line of stones. So we know this works. This is the very first base case. So this should definitely work. Let's just go ahead and run it. Now I'm going to start working through although now that I'm working through this, I'm realizing that the question is how many stones would I have? And right now, my blink method is returning a string. And I think I should just return the list of stones. So, what do I want to do? What do I want to do about this? I think I'm going to change this to be a listable long. That's another thing I want to do. I'm going to change wherever I'm using ints, I'm going to change to use longs. I think it's only here, right? Long. Because I don't really know how big these numbers could get, so I'm going to say long.parse. I'm going to say var transformed stones equals new list of stone. Actually going to return stone. Not stone, stone. And if it's less than 1, I'll just return my existing set of stones. And then in my tests, what do I want to do here? I think what I want to do here is I think I want to this is going to be stones. And I'm going to say var result equals transform stones. This should still pass. Oh, whoops. This should still pass. Okay. Now we're going to add our other tests. So after 2 blanks, it should be this. So we can say yield input. We're going to go through one time. What do you mean there's no? Oh. Okay, yield return sample input 2 should be equal to that, which it won't be. So if I run this, well, we need to build it. That's weird. Oh, yeah. Okay, so now what we need to do is we need to loop. So if for var, let's say var blinks equals 0, and then while blinks is less than times, we will increment blinks. And then each time we increment, we are going to get our transform stones. So actually, this can be equal to stones dot to list. And then we could say transformed stones equals transform stones dot select stone s dot transform dot to list, right? Cannot convert from list of lists. Is that what I'm? Oh, because that. Yeah, so each stone when it transforms could produce a list. So then I'm just gonna want to say, is there a flat or a um, uh, is there another method? C# flatten list. I don't actually know. Yeah, just select many. Okay, I'm doing the right thing there. Okay, so let's give this another run. Okay, so what are we doing here? After one blink. Oh. So after one blink, it should be this. Okay, run in. Two are passing. It looks like we're missing a 0. So I think what's happening is when we trim, this is even, and this is trimming everything. So we actually don't want to blindly do that. We actually left digits, right digits, and then we want to say, does trim return a new string? Removes from the current string. So we only want to trim them if left digits dot length is 0, no, is 1, is, excuse me, actually left digits dot length is greater than 1, then we are going to say left trim start. So I need to assign it like that. And then I do the same thing with right. If right digits dot length is greater than 1, then right digits equals think that will fix this case. Okay, well let's just let's debug this guy. Debug unit test. So we're looking for when it transforms this right here. So we step over, so 253. Oh, did I mix that up? If it's greater than 3 trim. That's gonna get trimmed to an empty string. Okay. So that actually doesn't fix my problem. So if digits are all 0, how do I say that? If so maybe math would be. I was thinking we want to keep these strings for this particular reason. Does this have any overloads? Yeah, that's tricky. That's a tricky one. What if we just did? What if we just parsed them? I know this is silly because what if we just parsed them? That parse. That parse. Sure. And then just said, instead of doing that, we do not to string. That's interesting. But it still is easier to deal with them as strings when we have to split them apart. Doing this is a lot easier than trying to... I mean, either way, coming from a long to a string, I still have to do that conversion. So this is fine for now. So let's try the next test. So this is gonna be 3 blinks, should give me this string. Yep, okay, we're on the right path. So now let's just go ahead and add the rest of the tests. Four, 5, 6. 4 is this guy. 5 is this guy. And 6 is this guy. Okay, one failed here. Oh. I think that failed because my case was wrong. Yeah, cool. And then just to test this, let's say test public async task link called it should return correct count of stone. Correct stones. Blink when called. Times. We'll say bar stones equals. Basically do the same thing. And we'll say bar one stone, or we can just say result equals. In this case, we're going to say sample input. This will be result server blink 25 insert dot that result dot count is equal to 55 312 55,312. That passes, then we can feel pretty good about our yep, okay, cool. So let's go to our terminal. Let's say .NET run project 11 Plutonian 11 input. Did I update my program? Sometimes I forget to do that. Oh, I need to write my tests. So I should say, or my console output. So I should say the number of stones is result dot count. Hey, there we go. It's actually pretty fast too. Looky there. Gold star. Gold star. Okay, on to part 2. Should have drank more coffee earlier. Now it's too late. Oh, shh. Really? Nice. This was a nice day. Oh, is this gonna be some deceptive thing, like where my like program crashes because it's some sort of exponential? Let's see. So the only thing I have to do is, well, first I need to update my problem. So all it wants me to do is run it 75 times now. The whole thing's gonna blow up. This is why I was saying that I think there's probably some sort of math to this, and you probably can't like brute force this, can you? To be fair, the infinite corridors are very large. Okay. Well, about to find out what happens. So I can just say var times equals is part 2. If it is part 2, we do it 75 times. Otherwise, we do it 25 times. We just say the number of zones is blank. Okay, let's see what happens. Part 2. It's just gonna sit here and spin, isn't it? So I'm guessing there's some sort of way to do this without brute forcing. Clever. Wonder how long this would take to actually run to completion. Yeah, I know. We may be waiting here long, or I may be waiting here a long time. The thing is I'm not really certain what the trick is. Am I gonna crash my computer by letting this run? My RAM is at 92% usage. This thing's still running. Okay, so let's think about this, because obviously I'm gonna let this run, but obviously this is not there's an optimization here. So okay, let me stop this because I'm afraid this is gonna cause an issue with streaming. So maybe we don't need to build up the list. The other thing I'm thinking about too is we're doing the same work. Like, for example, in this one, where are we? For example, like here, for example, right? We have to do, if each one of these numbers is a stone, we are doing the same work for this stone and this stone, but the result is the same. So we already know, like after we do this stone, 2, we know 2 translates to 2 times. Yeah, 2 is going to be, because it's odd and it's not 0, so that's just going to be 448. But then we do it again here, but we already know it here. So maybe there's a simple way where we could build up a dictionary where we basically say, hey, for this number, you get these stones back. I don't know if that would make it. I don't know if that makes it much faster though. But that's where my mind's going. So, what I'm gonna say, I'm gonna change this, and I'm gonna have a dictionary. I'm gonna have a dictionary called bar transformation map. I'm gonna say this is a new dictionary. Type long. Type list of long. Or no, type list of stone. And my stones are records, so could this be a hash set? Does that make sense as a hash set? I'll do dictionary. Let's start with the dictionary. This is the idea I have at the moment, so let's just pursue this. So we say for each bar stone in transformed stones, or we do this for each stone. Do a new list of stone. We don't really want to keep building this up. Yeah, I'm just gonna leave it the way it was. I think I need to bring this. Yeah, I think I need to bring this here. And then I think I need to do this. This. And say the first thing we'll do in a loop. No. We put this back. Stones. We're gonna return these. Var transformed stones. Just do this of stone. And you're gonna say for each stone we're gonna transform it. So we're gonna say var. Or no, for each thing we're gonna do is we're gonna first check the map, and we're gonna say transformation map dot try get value, which is gonna be equal to key, which is the stone, and then out stone. So if it is already in the if the stone that we're trying to transform already is in the map, then we can say transformed stones dot add listing and continue. Just continue. Otherwise, we need to say transform stones dot add range stone dot transform, and we also need to say that there, that there. We need to say, oh, and we also need to add, we actually need to say var newly transformed stones equals stone dot transform. And the reason we need that is because not only do we want to add them to that list that we're building, we also want to stick it in our dictionary. So we'll say transformation map dot add. The key is our current stone. It's a newly transformed stone. Then at the bottom of the for each, we want to say stones equals transformed stones, so that on the next iteration through here, we're going to iterate over the newly transformed stuff. So let me test this against our existing tests to see if they still pass. Okay, so they still pass. Now, let's see if that made any type of performance difference. Does not look like it did. I mean, it's saving me some amount of processing. I think it is, because, well, let's just test it. Let's test my theory. So the idea being we should be able to pluck, when we get to this 2, we should be able to just pluck 448 out of the dictionary. So let's hit that. Go to the observer tests. Let's just debug this one. So we do hit that. Existing transformed stones. And what is the stone that we're on? 1. Yeah, any 1's always going to give 2024. Um, 20. So what's the current stone? The current stone's 2024. So any 2024 is always going to give back 20. And yeah. So I mean, I think it is somewhat more performant. But I honestly don't know how long this should take to run. I wonder if what's taking the most time is me building up this list. I wonder if I just use, what are you making? Oh, hey, Shadow of Loki. I'm not making anything actually at the moment. I'm doing Advent of Code. I don't know if you've heard of it. It's like 25 days of puzzles that are all Christmas themed. It's pretty cool. It's a pretty cool little project. They do it one every year, and my first year doing it was last year, and so I had a lot of fun. So I came back for year 2 this year. And so today's puzzle seemed relatively straightforward. Um, you're basically just performing kind of a transformation of a string into other strings based on some logic they've defined. But it's pretty sneaky because they basically had you do it 25 times, and it runs lickety split. But then they 3x it on part two, um, and so if your code isn't very performant, this is kind of an exponential type of issue. So it just the runtime blows up on you, and that's currently what I'm trying to figure out how to optimize that runtime. Um, I think what I'm gonna have to do is I'm gonna have to let go of returning a list of stone here from the blink, and I'm just gonna have to return a result account. Because again, you get to a certain point, and anytime you see, for example, anytime you see the number 2024, you don't really need to do this calculation because you don't really care about these individual numbers. You just care that 2024 increases the count by 2. So I'm gonna kill this guy. I'm kind of interested if I let that run, how long it would take. So I actually think I'm gonna leave that for my own experimentation later. Like, I also wonder, could I parallelize this at all? Um, I kind of feel like I could. So let me copy this, paste it up here. And let me comment this out. And I'll put it to do here. How long would this take to run? To do if I make parallel, is it feasible? So basically what I think I need to do, instead of actually building up this dictionary of stone, I actually think what I need to do is build up a dictionary of stone, and then the count. And let's just use a long for short. And then instead of returning a list of stone, we're actually just going to return a count, which is going to blow up my tests. I'm going to have to rewrite my tests, but this needs to be a long. Then this needs to be, if times is less than 1, then it's just going to be stones dot length or stone dot count. Otherwise, what's going to happen? Otherwise, for each stone, we're going to try and get the value of the stone. In this case, it's just going to be a count. Then I no longer need to build up this list either. So now all I need to do is just say stones. This actually just can be stones count. And that equals stones dot length to start with, or stones dot count to start with. This can be that. And each stone in stones. Hold on, wait, I have to keep building up the list though, don't I? Yeah, I can't get away from building up the list. Well, no, I can still return. I can still go back to returning long. Yeah, I don't know if that's any more performant than what I'm already trying to do. So, what am I trying to do here? I know this is slow, and I know it's slow because I'm doing a lot of duplicative work. So I definitely need to keep track of the stones. I definitely need to keep track of the stones count. So that can still start at stones.count. And this ultimately is what I'm going to return from the method. And actually, I don't even think I need that check up there. I think that's redundant. But I think what I can do is I can say, okay, if this stone is already in my existing, then I can say resulting stones. And I think here I can just say stones count number of resulting stones. This would be a long. However, if it wasn't there, then I do need to add it to my list so that I can do the transformation. Or no, I need to do the transformation, and then I think I need to keep track of that. And this just needs to be dot count. Yeah, and so then that's no longer, that's just a number in this new world. But in my tests, so long. Yeah, none of this is valid anymore. Which really isn't a problem because I can just basically turn this into a count and say, so expected stones. This can become a long. Then we can just go, this should be 2. This is going to be 3. 1, 2, 3, 4, 5. This is 5. 2, 3, 4, 5, 6, 7, 8, 9. This is 9. 1, 2, 7, 8, 9, 10, 11, 12, 13. This is 13. I think this is 22. 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Should give me 22 stones back. So we can say test case dot expected this is just going to be resolved now. Okay, so let's see if my tests still pass. Ugh, I broke everything. Expected result to be equal to 1, but found 2. 4, but found 2. 5, but found 2. 9, but found 3. 13, but found 5. So I'm way off now. Oh, because I still need to increment the count, right? So I still need to say stones count plus newly transformed stones count. Now let's try again. Fine. So I'd be doing this. I should be doing this in this circle, shouldn't I? So I'm way off. Need to remove that here. Equal to 3, but found 5. Well, let's see. I'm trying to cut down on loops, or I'm trying to cut down on the need to track as much. Um, so I think I hate that I put together this nice solution to part 1 and I'm having to hack it all apart. Um, Okay, so let's think about this. Let's think about this more systematically from this dictionary approach that I have in mind, where the first time I come through, right, I've not seen 125 before. I've not seen somebody's already figured this out, and I'm so 125 becomes 125 it's kind of funny, but like 125, I care what number it yields, right? So when I mutate 125, it adds one to my stone count, and then it results in a new number of 2530. Which is good because I want to know that. So after this iteration, I basically have a dictionary should have a dictionary started. Let's say this is my dict, and this is my stones, right? And so my stones right now equal 125 and 17. Okay. So then 17 results in 2 plus 2, and it yields the numbers 1 and 7. Now, this is why I was thinking in the dictionary. This is why in the dictionary originally I thought I could just have a long, because then after my iteration, what I want to happen is I want to have a dictionary that's essentially this. It's essentially 125 goes to 253 like this, and then 17 becomes 1 7. Then my stones become this. And so my thinking is that by building up this dictionary, I save time eventually, because when next time I see redundant numbers, just look them up. So let's just rethink. Let's rethink this just a little bit. Yeah, transformation map. And this is what I'm gonna rewrite at the end of each one of these loops. Right, is going to be stones equal new stones. So I have to keep track of those new stones. Bar new stones equals new list of stone. I feel like I'm writing the same thing again, but with each iteration, that's what I need to do. With each iteration, I need to keep building up my dictionary and need to keep replacing my stones. That's not, I don't feel like that's saving me any time. I could say new stones dot add range existing stones, and then I could say otherwise transformation map dot add stone or or resulting stones equals stone dot transform, which again I think puts me back where I was. Just going in circles. Just going in circles. New stones dot add range. And I think if I was to return stones dot count, I think that would fix my tests. That would fix my test. But I don't think it makes me any faster. .191. I mean, it's half. It's half. I think the first time I ran this was 100 milliseconds. Which is the right answer. part 2 is still gonna just sit and spin. Maybe if I had a better idea how long console, I mean, this is going to slow it down, but console.writeLine running link. Every loop is just gonna take more and more and more. I mean, if I let this run, I think it will succeed, I think. There's gotta be some trick to this. What it is, I don't know though. I thought it was like a dictionary lookup like that to save time. Okay, what if when I hit this place, I don't add to the new stones? What if I just say stone count plus existing stones count? If I set this to 0, what if I do plus stones count? Does that save me any time in part 2, even if it's wrong? Much quicker. So that is the key, is not to keep adding the already computed stones to the list. But I'm off by 1 and I'm off by 18. Let's take a look at this one in more detail. Okay, so what if here what if here I do my stones dot count plus resulting stones? Some have a lot more, some don't have enough. Should it be new stones? Stones count plus new stones. Didn't change anything. So we get here, if it's 0, it's not returning anything. So this really should be stones dot count, like that, which should fix this test. It's going to screw that test up. Cancel that out. 3, but found 2. Let's step through this. Debug. Make this a little bigger too. I always get stuck working in the tiny little window. I forget I can make it bigger. So step over this. We have 2 stones. We're going to iterate over it. How many times? We're going to blink, or times. We're going to blink once. Okay, so we shouldn't really ever use the dictionary here. It's going to be 1. Step over. Step over. So 2. Okay. So new stones count is now 3. Stones count is 4. So, is what I'm doing wrong here? It should just be stones count equals that. Why does that fail? $125. Transform. That yields a new stone. We add it. Cool, cool. New stone count as 3. Now we have 3 stones, which is right. After 1 blink, we have 3 stones. Okay. It's 3. Okay, and the next time we hit this, we should be on blink 2. We should have 4. Yep. And then the next time we hit this, we should have 1, 2, 3, 4, 5. Blink 3. We have 5. Over. Over. Stones 2. Four. So what am I missing? 5, 12, 72, 2, 0, 2, 4, 2, 8, 6, 7, 30, 62. So I'm missing 20, 24. And why am I missing that? Because I already saw 1. Are count equals stones. Count. That fix my issue. So the count needs to. We're adding way too many stones. Adding way too many stones. It's like I know this is like staring me right in the face. What I need to do, and I just can't figure it out. Ah! So if I leave it like this, I'm going to be low. Yep. So this is 1. I hit this again when it's 0. I hit it again when it's 2. Plus the existing, plus the 2 that I start from. But honestly, I don't care how many I start from. I mean, I do, but I don't. What I care is how many are left at the very end of all the transformations. So the first time through, this is 2. This becomes 1. This becomes 2, right? So what I care about is on this iteration of the blink, how many stones do I end up with? Two. And at the end, I should be existing stone. It's like var count equals 0. On this blink, I go through, and the stones count. On this blink, the stones count gets set to new stones dot count plus count. Found 9. Oh. 11. $34. So, what happens if I start this at 0? Okay. And what if I add the original? What if I do that here? It fails. But this one makes it slow. Incredibly slow. It makes it impossible to finish. Ugh. What have I done? Stuck. Hmm. Okay, so what if I do this? Okay, let's think about this a different way. What if there's a cycle? Now, I honestly don't know if there is a cycle, but if there is a cycle and we only see like similar sets of numbers, that's kind of that's an interesting idea. So I'm thinking if there's only ever a certain number of numbers based on this pattern that we're processing, um, then could it be as easy as just transforming a stone, getting those two numbers, seeing if we've already seen them before? If we have, we increase the count of the number of times we've seen them. If we haven't seen them before, add them to so keep basically a dictionary of numbers we've seen and the number of times we've seen them. But I honestly don't know if that's how this works. So let's do this. Let's go back to the way we were doing it. Let's remove this for a second. Let's not worry about count. Let's say stones. Say stones. Yeah, that's right. We'll say stones length, which I think lets our test pass. Yeah. But let's actually console write these. So let's say console dot write line string dot join space, and we'll say stones like that. Oh. We want to do this inside the loop. That's too fast. I can't see that. So let's write it to a file. Or what if I do stones dot what if I do bar all stones equals stones to this? And what if I say stones dot add range, new stones? And then what if I do all stones dot distinct dot count? So they're all distinct. It's ever increasing. Does that make sense? Well, I'm out of ideas, so let's try the idea I had. So the idea I had was transform the stones, have a dictionary. That's going to be equal to new dictionary of stone and long, because I don't know how many are actually in here. And actually, I can call this, I can do, actually what I can do is I can say stones dot to dictionary, and I can say S goes to S, and then S to S dot. How do I count them? I basically want to count or could I group them? Group them by S. And then to dictionary is now it's a grouping. And so I say the key is going to be G dot key. And this is going to be G dot count. Basically, the idea here is I should get a my count can't be. I need to cast this to a long, just in case. I don't know how big this is going to be. Yeah, and then we'll go in here and we'll say for each bar result in resulting stone, say if stone dictionary dot has dot try get value. If it has the result, then we should have out count. So that oops. But I'm trying to basically keep track of the number of things there. So do I just want to add one to the count because I've seen the number again? if the stone dictionary dot contains this key, then stone dictionary results equals I can't decide what I want to count. Do I want to count the number of stones that this stone yields? Because that's essentially what I'm doing, is I'm saying this stone is equal to 2 stones. And then if I see it again, I just increment it by that many again. So the first time, let's just use this as an example. So the first time through, we're going to say 125 yields 1. The next time through, we're going to say 117 yields 2. But how does that get me to the how does that get me to this? Well, how would this even work? That's the simplest, and that runs successfully. But what does the dictionary get me? The dictionary gets me because the length of these stones just gets exponentially long. Oh man, this one's got me down bad. It's got me down so bad. I mean, I guess if we look at it in the okay, stick with me. We say this is fine, but then but how do we avoid getting to this? How do we avoid getting all the way out here? Because at this point, a lot of duplicate values in here. But maybe what we say is something like, maybe something we say is like, maybe we don't iterate over because this is the problematic piece. This is what's problematic right here. So if we didn't do this, what would it look like? If we didn't do that, so if we did for each bar count, um, then you said bar stone transformed equals stone dot transform. And then you said if stone counts dot stone, then you do stone counts stone plus transform dot count. Otherwise, you initialize that stone. So, so A for now. For each stone. So do it for each stone. And then at the end of the loop, I overwrite stone counts. I don't need to override it because I'm transforming it here. Then what I do stone dot values dot sum, like that. I think this works on the first pass, but I don't know if it works after that, right? Because the first time we come through, it's not going to have a stone. It's not going to contain that stone. Or no, it is going to contain that stone. So it's going to be this. So what's the point of doing the transformation if I don't use it? Let me just run one of these. Yeah. Vector result to be 3, but found 5. What happens if I always do this? Result to be 4, but got 3. No, that doesn't make any sense. I'm on the struggle bus right now. on the struggle bus. You can't. So I have to have two different dictionaries. Our next count. Let's do dictionary of stone count. This. For this year. Which feels very similar to what we were doing before. Okay. Is this gonna work? Holy shit, that works. Okay, so what did I just do? Okay, first of all, hold on though, let me make sure this gives me the same. Wow, way faster. It's a fourth of the time. Okay, now the real question though is, does it deal with part 2 any better? What the fuck? Okay, so I need to step through this to understand. So this is basically the idea I had, where you're building up a map of the stones and the count. And so let's go to the test file. Let's start with this one. No, this one. Let's debug this one. Oh. The stone count starts off at 25 with the value of 1 and 17 with the value of 1, which makes sense. Now what we're going to do is we're going to destructure those stone counts. So now we get a stone and we get a count out of here. Right now our stone should be 125 and our count should be 1. We're going to transform that, which gives us 1 new stone like that. And then we're going to for each over those, and we're going to say, hey, if this dictionary up here already contains this, take the current count and add it to it, but it doesn't. So we step over here, and we're going to create the first entry in our dictionary. So now this guy up here holds 1 new thing. It holds this, which is great. Now we're looking at 17. So stone 17 when transformed gives us 2 things back. Again, it's not going to be in there. So we proceed. Now our dictionary has 2 things in it. 1. Not in there. Now our dictionary has 3 things in it. Okay. Yep, that should have 3 stones. Okay. Now we reset the dictionaries. We increase the blink. Now we're looping over this. I mean, all we're doing is we're building up a dictionary with a count of 1 every time. right? Yeah, I mean, this is just count of one. I mean, does this ever get hit? Uh, 5, 12, 72, 20, 24, 2, 0. Oh, yeah. So it does get hit quite a bit. But doesn't that mean this keeps incrementing? So let's debug that again. This count. That count's only ever increasing it by 1. God, it's just so much faster doing it that way. Let's try debugging this. Debug unit test. Debug. 3, like 5. Oh, okay. Yeah, now it makes sense. Okay, so if you think about this, stone, right? Let's see. Yeah, that's our stone. But if you think about stone counts, right, we have 16 items that we're looping over right here. And we're only ever looping over 2 here. This, I think, once we reach 25, is going to be incredibly lower. An incredibly lower number. Let's see, stone counts, 23. So even when we get up to 25, how many are we looping over? So our total stone count is increasing for sure, but it's not increasing at the same exponential. Let's just jump forward a few loops. Okay, well, let's jump to here. So that's the difference. By having that dictionary where we're looking at, instead of generating all the stones and then looping over all those stones, we're generating the stone and keeping track of one dictionary and just incrementing when we've seen it. Yeah, so stone count is what? Stone count's 2. Then it goes to... Let's see, once we get up to... I want to see, once we get up to 25... 24, sorry. Once we get up to debug unit test... Get up to blinks 24. How many stones do we have? $50, $55 something. Now doing it the other way. It this way. Doing it this way. Get rid of this because we don't need that. This way was actually don't need that. This we could actually say we also don't need this. Link, which is gonna be bar. There's gonna be stones equal stones dot select dot transform dot select mini to. This is what we were doing originally. And we'll turn this into a long. And actually this, so that I can see, I'm going to call R equals transform stone dot add range stone dot form. Then stones. And I think on the smaller thing, I can do blink slow. I think it'll give me the same. Yeah, it'll give me the same answer, but I'm going to have a number up here that's our number of iterations equals 0. Iterations plus plus. Debug. This should be pretty hot, pretty high. Yeah, look at that, 105,820. Here though, it's going to be far less. So if I said var number of iterations 0. Say let's change this back to blank. Yeah, I mean that's look how look how many orders of magnitude that is. That's 100 and something thousand compared to 1,500. Yeah, that's wild. I knew I was close, and I knew the way I was thinking about this is like we're gonna see numbers multiple times, and so there's no reason to iterate for those multiple numbers. We basically just need to know we've seen it, and when we see it again, we update a count. And so that's what my map finally lets me get to. I am gonna do something with that. I'm gonna say console dot write line link. What are we gonna say? We say number of iterations required to solve. Say the same thing up here. I just our slow result equals learner.blink slow. This is going to be my fast result. And no. Just for my own play, I guess. So I want to say part 2 took 184,828. Part 1 just took 4,000. Part 1 slow takes 36. 369,000. So what is that? What orders of magnitude are we talking about here? That was for 25 iterations. Yeah, that's crazy. Lesson learned though. So what's the takeaway here? The takeaway is if you have to successfully iterate and do transformations, it's better to keep track in some sort of hash map or a dictionary like this what you've seen on each iteration, and then on the next iteration don't try to recompute everything and iterate over it, right? Because that's all I'm doing. Instead of the inner methods is the only difference, right? So for each stone, and instead what I'm doing is I'm saying for each stone, transform it, look at each transformation from that particular stone and see if it's in this next count. Okay, let's we actually need to see if my part 2 is right though. I haven't actually done that. So let's see if part 2 is right. Woohoo! Oh man. Okay, so let's take out blink slow. Let's take out this guy. It's not really a part of the solution. Take out this. Don't think we need to do this. The extra allocation that we don't need. Yep. Then let's add some tests for our puzzle input. So let's say blink, or no, test, and it's basically going to look just like this when called with puzzle input in 25 times. Should return correct number of stones. Now what we'll do is we'll say bar input equals await get puzzle input async task of string inputs await file.read all text path combined the app context space directory and the name of our input. This is going to be How do we do that? So what was return to advent calendar? This guy. Then 2, 5. Success. Okay, and then I'm just going to refactor this because this is not going to get any better than what it is. Oh yeah. Pebbles. And this one is Plutonian Pebble. Yeah, that was a tough one for me. And I just kind of stumbled on this. I mean, I knew where I was going. I knew what I wanted to do was have a map between the numbers I'd seen and how many times I'd seen them. But this really doing a second dictionary really came out of that error message I got, and that's what fixed it. Was using a basically instead of using a list and building up a new list and resetting that list and the list getting longer and longer on every iteration, longer list, longer list, longer list, longer list. By using a dictionary, the list got longer on every iteration, but nowhere near as long as it was using a list. Okay, that's gonna do it for me. Oh, I should update the README, shouldn't I? I wish I had it in me to solve multiples of these in a day, but I'm not that good yet. I need a couple more years of practice. Dictionary greater than list. That's all I'll say. That's all I'll say. That with the prettier. It's done. Now we can commit all this. Okay. Feature solved day 11, part 1 and part 2. Let's go. Commit and push. It's sir. Vote. Rename. Origin. Okay, that's gonna do it for me. Thanks for sticking with me. This was one of the longest ones yet. This was, I think, right around four-ish hours. Part two really whipped my ass. I got part one and I was like, oh, this is gonna be easy. Part two is gonna be a piece of cake. Not so much. I'm sure for other people the solution was like blatantly obvious from the get. But you know, live and learn. Live and learn. I'll see you guys for day 12.